Welcome back to Ask Jerry and Ray anything about IBM Z. And today we're asking, what's JES got to do with it? I promise you we won't sing our rendition of the Tina Turner 1984 classic. You don't want to hear that.
Yeah, and we do want you to come back, so. Well, all right. What are we going to talk about today? We're going to take a look at JES 2 and its role in IBM ZOS. Then we'll look at job entry and job management. And if you have a job, ideally you'll get some output. So we'll look at output management and distribution. Then we'll take a look at resource control and scheduling. How does JES schedule jobs, make sure that everything flows smoothly? And then we'll end up looking at job status reporting and error handling. So Ray's going to get us started with Introduction to JES 2.
Yep, and today we're primarily going to talk about JES 2. There is another flavor of JES, JES 3. IBM has handed over the control of that to, I believe it's Phoenix Software. They're doing the management of it these days, but IBM no longer officially maintains it. So today, we're going to talk about JES 2 and why it's important. So we've been talking all this time about JCL and submitting it to the system, but where does it go? Well, it goes into JES 2. It is the job entry subsystem. So the job comes in, it defines some resources it needs, whether that be memory, storage, tapes. Just make sure it gets it, and it makes sure it gets it in a good order. If it's a high priority job, it gets to cut to the front of the line. If it's a low priority job, we'll get to it. So what does JES do with jobs? Well, it does it takes the jobs from the input queue. It does whatever resource allocation it needs, and then, you get your output. My dad likes to joke about almost anything, right? Data comes in, data goes out. Just kind of directs it. So kind of the overview of crap, I haven't read this slide yet. I really hope that Dolores is keeping some of these for like maybe a blooper reel at some point. Usually I can just kind of wing it because I've already read the slide, but last night was oof. Let's see. Okay. Yeah, so then the basic overview of JES, as we've said, it acts as the interface between the operating system and the user and their jobs. So, JES will take your job in. It is specifically designed for the IBM ZOS operating system. And so it works very closely with the operating system, but it is not necessarily the operating system. I would almost want to say it's not really part of the operating system, because way back when you could have an operating system but no JES. So JES did come along at a later point, allowing this efficient entry and management of your jobs and started tasks and whatever else JES is controlling at the time. So how it goes into the workflow, though, is, again, jobs come in, data goes out. So it receives the job, it schedules it based on these priorities. Different teams might have a different initiator designated to them, and so it'll put it in that queue. Priority goes up and down, as we've said before. It does a lot of your output management. So if you say, when the job writes a message to, the system log or whatever, also include it in, this job log somewhere else. Sometimes it's just with the job in JES. Other times you write it to a data set. Again, JES is the one managing all of these resources, and so it puts everything into the right spot when it needs to be in the right spot. And so JES will also communicate the status of the jobs to you. There are a lot of different ways to get status of a job. There's an FTP interface into JES where you can submit jobs, you can get status of it. From your TSO ready prompt, you can get a status of a job. And then, of course, from SDSF, which is the interface into JES itself, there are different panels that will show you, again, your job status, started task statuses. You can see APF lists, link lists, even coupling facility information. They have expanded the amount of information available to you drastically, even since I started. And that was 16 years ago. Feels like it's been a lot less than that, though.
Time flies whether you're having fun or not.
Time waits for no one.
Absolutely. All right, so now we're going to take a look at job entry and job management. First off, we've been talking about batch jobs, and the interesting thing is that everything that comes into the system just treats just like a batch job. So if you have a started task, if you want to start TSO, you want to start CICS, JES gets some JCL, and so that's the input part of it, and then it converts it. And this is the phase where if you left out a comma or there's some type of syntactically incorrect specification, JES will then say, oh, you have a JCL error. Here it is. It tells you precisely what it is. Even though it may not be clear to you, it's specific to whatever the problem is. And you need to fix it before you try it again. This applies to your started tasks, it applies to your TSO sessions, and it applies to your batch jobs. They all go through the same process, and JES is responsible for all of it. So after it converts it, it puts it in internal text out in the spool. The name of the spool by default is sys1.haspace, HASPACE. So it sits out there and it waits for the right time for it to be executed. Now, if it's a started task, it starts immediately. If it's a batch job, it has to wait for an initiator to come available for it to then run. So when that initiator comes available, JES says, okay, fine, here, you go here and you run. So it does all your, at this point, JES is kind of sitting on the sideline. Ray talked about the communication of the statuses. It'll say, okay, fine, this job is running. It's in step 1, it's in step 2, it's in step 99. It'll tell you as it processes where exactly that job is. Then finally, the job will end, ideally successfully, but if not, it will also tell you that job got an ab in, 322. Whatever the problem is, just informs the user of, okay, this job ended, it ended badly, or it ended well, and then you get a chance to go and take a look at the output. You know, JES has a whole list of this step ran, when it started, when it ended, tells you the condition code, and any other output that is produced, JES processes that. Now, in our diagram, we have the output going to print, but that's not the only place that output can go. You can write to a data set. You can write to cards, even though I don't know if anybody still does that. But all of the output is controlled by JES and determines where it goes. So JES ultimately will purge the job out of the system. Now, a lot of that is under your control. It says, okay, fine. I've looked at this job. I see it's happy. I'm just going to let it sit in the queue for a while. It'll stay there until you explicitly purge it, or the operators have a command that purges jobs that have been out there for a certain number of days. So all of this is the processing that JES executes when you hit submit. or start a task or log on to TSO. So it receives input from the sources. You have batch, you have remote terminals. You you can have a job that submits another job. So JES doesn't really care. It treats it all the same way. It grabs that JCL, it converts as we talked about, puts the internal text out in spool, and then runs it, handles the output, and your job is done. Um, we have rule-based job processing. What does that mean? They have rules that determine when this job should run. It makes sure that it has the necessary resources. If it sees that you've got a disk equals old data set and that data set's allocated, it'll say, okay, you this job is waiting for data sets. So whenever you get ready, free up that data set and this job can proceed. If it's a batch job, you're actually tying up an initiator because JES said, okay, fine, it passed conversion, so let me go ahead and start this job. Finds an initiator, starts it up, but if it's waiting on data set, it sits out there waiting on data sets until that data set becomes available. And then we talked about the queues. It has the input queue, it has the output queue, it has executables. All of that, all of those various queues are controlled by JES so that you have orderly and prioritized execution. So everything goes orderly. And without JES, it would be kind of a madhouse. And I think that's why JES came into being. Back in the day, you know, jobs would just kind of sit out there and somebody would take it and they'd run it. And, well, oh, I was supposed to run this job first. JES controls all of that, takes care of everything, and makes sure that everything runs in the right order. So the job queues are based on priority. Um, you assign priority levels. You can assign priority level by class. You can explicitly state the priority order for your job. And it also handles things based on resources. So it handles resources efficiently and avoids conflicts. And then the scheduler uses all these two items, the queues and the priorities, to efficiently schedule jobs, minimize conflicts, and optimize workflow. So it's trying to make sure that everything gets run efficiently in the best way possible. And you have to assist JES by saying, okay, this is a payroll job. It jumps to the head of the list. I don't care what's running, we got to get payroll out. Oh, this is one of Jerry's reports. We'll put him back in the back of the queue somewhere, and sooner or later it'll run, and then he can look at his output. So your specification determines the priorities that JES works on. And so we talked about all the various statements, the job card, the execute card, the DD statement, and this just makes sure that you remember what we talked about in the last three episodes, where we laid out all the information about JCL. So we've talked about that. Now Ray is going to talk about output management and distribution.
So, as we said, jobs go in, data goes out, usually. And so, where does it go? Well, just takes, some of that output, and if you say, say DD, your output file is DD sysout equals splat, right? That means just write it out to the, JES spool with the job information. And so JES captures that, keeps it with the job, and then, you have access to it for, as Jerry said, as long as it's out there until it gets purged one way or another, whether you do it manually or the system does it automatically. Some places have output, what do they call it? An output aggregator, where they offload, all the jobs that ran today. They get put into, different roll-up area. And then, man, something just, something just messed up with my eye. Okay, wait for the camera to readjust. Okay. And so once the output's been gathered, it has to be, it's systematically managed. Wow, I'm good. Words are good today. And so when you systematically manage your output, again, you can easily keep track of it. If you need to keep something on file for, we'll say 7 years because of whatever your data retention policies are, you can take that output and offload it somewhere and then, put your data management retention period on it and keep it for as long as you need. You can also prepare this output for printing. You can also prepare it to write to a data set. So once everything's been run from that job and it's sitting in there on the output queue, you can actually take it and write it to a data set. If you don't want to keep it on spool, if I run a job and I don't know if we have, a nightly backup of or a spool offload of everything, I want to make sure I have a copy of this. So I'll go over there and I'll type it's an XDC line command next to my job name, and then I will go ahead and keep the output. And again, the output goes to the right places. You can put, there's a line card on your JCL that's called route equals, and you can send it to a printer, you can send it to a different system. Again, you can send it to an offloader. There's a whole bunch of different places that you can send it, and JES will take it and try and put it into the right place. And each of those things are defined to JES as, an output destination so that it knows where to put it when you say, oh, send it to printer RMT 235. It knows exactly where that is, what the printer's definition is. Is it a green bar printer? Is it, legal paper? That information's actually available to JES. So again, it puts everything where it needs to be in the right way at the right time.
And that's an interesting point because when I came up, you had the data center, and like 99.9% of things that happened in the data center. Now there are things all over the country, all over the world. So you may take this output and send it over to another country, and a printer in some other country starts printing the output from your job because that's what you told it to do. And JES handles all of that. So that's a historic perspective.
And this is kind of, again, rehashing what I was talking about, where you can send it to a physical printer, you can send it to an electronic output, such as your job offloader or spool offloader, data sets, and then your queue and format management is, it's managing everything that comes in, goes out, and it makes sure that, well, if it starts getting full, it's going to send you messages. As Jerry said, there are commands where you can just purge anything that's older than a certain amount, or older than a certain date, or taking up X% of the spool. There's some commands that make it really easy to manage the data out in the JES spool. And a couple times I'd say it's not very rare, or it is very rare, for these kinds of things to become an actual problem, because most of the time there's some kind of an automatic product or subsystem or something that will take care of this for you, again, based on whatever rules you set up.
And while you mentioned that, I've seen runaway jobs that are filling up the spool, and JES becomes a toddler, a unhappy, uncooperative toddler when spool gets to 100%. It folds its little arms and says, I'm not doing anything else until you get something out of this spool. So at that point, you have to find out the job that's filling up the spool, handle it, get the spool back to its normal state, and then then JES regains its maturity. So.
I don't know which is worse, JES spool filling up or the master console buffer filling up.
True. Well, see, and if the master console buffer fills up, you can't see anything else. It just says, "Hey, I'm
Right.
done. You're in
Yeah.
trouble now." So it's just a matter of which toddler gets control first. So, all right. So let's move on to resource control and scheduling. Sorry to toddlers everywhere because Jez is much worse than real toddlers. All right. So Jez monitors CPU and memory resources to trying to maintain system efficiency and job performance. So that's his job. It says, okay, I want to make sure that we kind of keep things balanced. We don't let one job run away and run away with everything. And that's part of his purpose in life. Dynamically allocating resources to make sure that everything flows without conflict. And it says it keeps the jobs isolated so that if I know that if this job is using up all of the CPU, it'll take some steps to let somebody else get another chance, another shot at it. And there's a component called workload management that handles all of those things. It makes sure that all of that stays balanced. So we're covering this information again. Jobs are scheduled based on priority. We have initiators that are set aside for certain jobs, um, and all of you can. I'm not going to read this because you can read, but this is how jobs are scheduled for processing. That's one of the primary responsibilities of JES, as well as making sure that jobs don't conflict with each other. So it tries to make sure that everybody's happy. We're one big happy family, and that's what JES wants to accomplish.
Yeah, getting stuck with resource contentions is another one of those really bad problems to have where job A has dataset A and is waiting for dataset B, but job B has dataset B and is waiting for dataset A, and you get stuck in this deadly embrace and nothing moves. So we'll take that and roll into the status reporting and error handling. You know, JES will give you messages a lot of times, like Jerry said, this is what's wrong, right? It'll point to the specific line in your JCL that says, oh, you were missing a comma here. It won't necessarily tell you that, but it'll say this line had a problem, and then you can go and look at it and fix it. But at the same time, you can also have a job that has a message that, again, says it's waiting for resources. It'll tell you which resource it is. It won't necessarily tell you what has that resource, but there are other ways to find out. If it's a data set, you can go into 3.4 and then, try to access it, and then, PF1, it'll tell you who has it. There's the ISR DDN NQ, there's GRS. There's so many ways to tell, what has a hold on something. But JES will at least tell you, this is where your problem is. And I will beg every one of you, please use Google. Look up the error message. Look up the reason code. IBM has phenomenal documentation when it comes to this stuff. Your support people will thank you.
And your support people will talk to you. If you call them every day,
Yeah.
then they're not going to talk to you. They will not be your friend.
Yeah, and if you can do a little bit of that investigative, investigation up front, before you hand it over to your support person, again, they'll, probably be a little bit happier than if you just say, it's not working. And so, basic error messages. Again, you'll get a message identifier, you'll get some descriptive text, you'll usually get a reason code or a return code, and then you can just go to whatever your favorite search engine is and just type in IBM message ID, and then, it'll come up with the IBM page that has that message. It'll have descriptions, Sometimes they're a little vague, but most of the time they're really good. You might have to take one message and then look it up in a different message. IBM's changed some of them. I'm trying to remember which ones they are. I want to say it's like an IEC 060 or something, where it just kind of chains depending on the reason code. And so that becomes part of the message ID. But yeah, troubleshooting is important because it's a skill. Not everybody has it, but everybody should have it.
Some people are better at it than others, but your basic fundamental troubleshooting is, as Ray said, you know, Google the error message. I've gotten really lazy and I ask AI, how do I fix this problem? And it comes back and tells me exactly what's wrong, tells me how to fix it. So, AI has really improved your throughput because you can Google something and it'll give you the error message, and the error message doesn't really make sense. And so then you have to dig into it. AI understands all of that. And as long as it's not hallucinating, you'll get good answers, and, and it'll help you fix your problems. It's not quite at the point where it'll go fix them for you, but I think that's coming. That's coming down the road.
Yeah, I need to get better at learning how to use AI and having it work for me. So then, going back to the status of jobs, what happens when it's done? Well, you get your status code, your return code. 0 means great, no problems. 4 means there might be warnings. 16 is usually not good. There was an error. But again, everything depends on, in this, in this line of work, it depends is always the answer. But, it depends on how the program was written. But typically those are some of the conventions that are followed. But when you run a job, you can actually, in the job card, put a notify card. And so when the job finishes, it'll pop up a little message on your TSO screen that says, hey, the job finished with this return code. Then you can go back to your JES viewer and start looking at the output to find out, okay, how was it? Was it good? Were there problems? Do I need to fix something and rerun it? And at the same time, just lost that train of thought. I swear I took my meds today.
We'll move on.
Yeah. Yeah, when you go to look at the output, you'll have your, the other part that I was thinking of when I lost my train of thought was, it'll tell you everything about all the data sets, well, almost everything, about a lot of the data sets that it used, right? It'll tell you what volume the data set was on. Sometimes it'll tell you storage class, management class, your different SMS constructs that were used, if you're defining it, or, if you're just browsing something that already exists, it'll tell you what volume it found it on. Because sometimes, not as much now that SMS is kind of king, but you'll sometimes still have uncatalogued data sets sitting out there, and sometimes people might uncatalog one and recatalog another one, so you got the wrong one. So that's another thing to look at when you're trying to debug a problem. Was it looking at the right data set?
All
And so
right.
that takes us to our conclusion here of what JES 2 does for you.
And like we said, you can read, so we won't read to you, but this is what it does.
I think I've rambled on about it a lot, to the point where I think people have a pretty good idea of it. The one thing that I got into a discussion with a technical group online is different commands. And so because JES 2 is very close to the operating system, it has a lot of commands that you would think might be operating system commands, but are not. And so we can get into that in a different video, where we go over some of the different commands, some of the different things that you can tell, is this a system command, is this a subsystem command, and it's important information to know.
All right. And we want to thank you for your time. Um, don't, for, don't forget to hit that subscribe button, the like button. And if you have any questions, send us an email and we'll be back next time.